Hi and welcome everyone, I'm Gavin Lon. So recently I released a video entitled, Is C# better than C++? If you haven't yet seen this video, please check it out at this URL. The link is in the description of this video. In the video, we look at a broad overview of the similarities and differences between the two languages. In this video, we are going to look at a basic code comparison between C# and C++, where we'll code the same basic app firstly in C++ and then in C#. So this can hopefully give us at least a cursory insight into some of the basic similarities and differences between comparing writing code in these two programming languages. You'll no doubt notice that my C++ is a little bit rusty, but because I'm proficient at coding in C#, I could fairly quickly become proficient in writing C++ code. C# is a descendant of C++. So many of the foundational principles in C++ have been adopted in C#. I emphasized in the last video that C# is a much easier language to learn than C++ and could be a great language to learn as a first programming language before learning a more complex language like C++. If you like this video, please hit the like button and please consider subscribing. Please don't forget to ring the bell so that you'll be notified of future content. Please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do this at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. If you'd like to follow me on X, my username is @GavinLonDigital. I really love reading your comments, so please feel free to leave me a comment. Your insights are always greatly appreciated. Right, let's get into it. So I'm on a Mac platform and I'm going to use Visual Studio Code to create this code example in C++. If you have Xcode installed, you should have the Clang compiler installed. I'm going to use the Clang compiler to compile my C++ code. So we're going to compare writing a basic app, firstly coded in C++, versus writing the same app using C# code. In both instances, we'll write the code using Visual Studio Code. With this application, I'm going to highlight a very interesting difference between how C++ code is used to store object data in memory versus how C# code is used to store object data in memory. So in C# and C++, the main method is the entry point for the application. So let's firstly create our main method. But even before we create our main method, let's create a file to house our application. So I'm going to call this file main.cpp. So the .cpp extension signifies to Visual Studio Code that this is a C++ application. Right, so to create the main method, we type int main, open curly brackets like this, and then we're going to return 0 like this, which means that if the code gets to this point in the code execution, that all the preceding code has executed successfully. So let's create a class named bank account, and we'll come back to the main method in just a bit to create the logic for our application. Right, so let's create the bank account class declaration. So in order to do that, we first type class, then the name of our class, which is bank account, like this, open curly braces. So we want to create two private member variables. One will be used to store the bank name and the other will be used to store the account value. So firstly, let's include an access modifier. So we want to include a private access modifier because we want these member variables to be private. We don't want any external code to be able to access these member variables. So let's include the private keyword here. Right, so let's create our member variables. So the first member variable is of type string and will store the bank name. So let's name our variable bank name like this. And the second member variable is of type double and will store the value in a particular account. So let's name this account value like this. Excellent. So let's create a constructor for our class. So we must name our constructor bank account, followed by open and closing brackets. Then within this constructor definition, we want to include two parameters. So the first one is of type string and is named bank name. And the second parameter is of type double. And let's name this account value like this. And then within the constructor, we want to assign our member variables appropriately. So we go bank name equals to bank name, like that. And so these are, of course, the values that will be passed into the constructor when the bank account class is being instantiated into an object by calling code. Then we want to set the account value member variable to the account value parameter value, like this. Excellent. So we want to create a method that can be called to output the values of these two member variables. So we want a method that outputs the bank name as well as the account value to the console screen. So we're going to encapsulate this functionality within a method named bank statement. And this method does not return a value, so we can use the void keyword to signify this. And let's call our method bank statement like this. Excellent. And then, in order to write our values to the screen, we type std : then we use the cout object to output our text to the console screen. Cout actually stands for character out in C++. And then we follow this by a space, then two less than symbols, then another space, and then the literal text, because we want to output the bank name first. So let's include the literal text bank name like this, followed by a colon, and then to concatenate the value that is stored in the bank name member variable, we include a space, followed by two less than symbols, then another space, and then the bank name variable like this. And then we want to concatenate an end of line or a carriage return. So we can do that by including another series of less than symbols like this, and then the endl function here like that. And let's make a copy of this because we want to now also output the account value to the console screen. So include account value, literal text here, and then let's include the account value member variable like that. Great. Okay, so now, in order to use the cout, the std : cout code like this, we have to include within our C++ file, we have to include the correct standard library, which in this case is the IOStream library. So to do that, we can include this line of code, #include, followed by IOStream within angle brackets, like this. Excellent. Great. And then the other thing is, when we're outputting a lot of text to the screen, we don't want to have to include std : every time. So to get around this, we can include the using namespace std code like this. Great. And then we can actually remove the std : code here, like this. And that should work perfectly. Great. Now, the other thing is we want external code to be able to change the values of the bank name and the account value. So at the moment, they can only set these values at the point where the code is instantiating the bank account class. But we want the external code or the client code to be able to subsequently change the bank name and account values. So to do that, we can include getter and setter methods for this purpose. So let's do that. Let's include a getter method for the bank name member variable. So string and then get bank name like this. Open and close the brackets, open, close curly brackets, and return bank name like that. And let's create the setter for the bank name variable, and we can do that with this code here. So this will return no value, so we can use the void keyword here. And then let's call this method set bank name like this. Open the brackets, and then within those brackets, we want to include a variable of type string, a parameter of type string, and let's call this bank name. And we want to do something fairly similar for the account value member variable. So let's make a copy of that, paste it, and change the relevant code appropriately. So we go get account value, and this needs to be of type double, and we want to return the account value member variable like this, and then we want to be able to set, we want external code to be able to set the account value. So set account value, and this method needs to accept a value of type double. And to keep things consistent, let's call this parameter account value like that there. And then we simply want to set the account value member variable to the value passed into this method like this. And of course, we have to do the same thing for the set bank name. I forgot to do that. So let's make sure that the bank name variable is set to bank name like that. And I think that pretty much does it for our bank account class. So let's write the calling code within our main method now. So firstly, let's instantiate a bank account object, and let's call this bank account 1. And to instantiate the bank account object, all we need to do is go bank account 1 equals to bank account. We don't need to use the new keyword like we would in C#. And then pass in the relevant value. So let's say that the bank is NatWest, the bank name is NatWest, and the value of the account is £20,000. Let's say something like that. And then let's output the bank statement. So to output the bank statement would be bank account 1 dot bank statement. So we are just calling the bank statement method here like that. And let's see if we can compile this code using Clang, the Clang compiler. Okay, so let's first invoke the console window. So we can press Control tilde like this to invoke the console window. And then within the console window, we type Clang ++ followed by the name of the file that houses our C++ code like this. Okay, we have a few little issues. Int main. Okay, what's the problem there? Oh, okay. Forgot the open and close brackets there. Silly mistake. Okay, could have been worse. Right, so let's clear that and let's Clang ++ it again. Okay, we got more errors. Of course we do. Okay, I think it's because we wrote the class underneath the main method, so we need to actually change the position of this class here. I'm just going to cut that and paste it here. Save our code, clear the console screen, Clang ++ main.cpp. Brilliant. So it's compiled our code. And we've got a file now called a.out. This is our executable. It contains the binary, so the compiled version of the code that we've just created in C++. And to run our code, we just type / and then the name of the file like this, a.out, and press the enter key. Great. And our code has executed perfectly. Brilliant. Okay. So now it gets a bit interesting. Okay. So let's say we want to assign a bank account object the value of our bank account 1 variable. And let's see what happens when we output the value for bank account 2. What actually happens here? So let's compile our code. Excellent. And let's run our code. Okay, so that's an expected result. So at present, the bank statements for bank account 1 and bank account 2 are identical, which looking at the code makes sense. But now what happens if we change the values for bank account 1 using our setter functionality? So let's go here, bank account 1 dot set bank name equals to, so let's make this TSB. So let's say we want the bank to be TSB, and then we want the value of the account to be £41,000, like this. Okay, let's clear the screen, compile our code, equals to, oops, of course, we can't do it like that. It's because I write a lot of C# code. It's not a property, it's a method. So we've got to pass in TSB here and do this, and do the same for the set account value. Okay, so 41,000 like this. Okay, brilliant. And that should remedy our problems. Clear the screen. Clang++ main.cpp. Hit the enter key. Right, that's compiled perfectly. Now, let's run our code. This should be interesting. Excellent. So this is the point I wanted to actually make. So by changing the value for the bank name and the account values for bank account 1, it has not affected bank account 2 in any way. So if this was C# code and we had written the code in a similar way, this code would have actually resulted in the value for bank account 2 being automatically changed when we changed the values, the corresponding values for bank account 1, which is interesting. It's just to do with how C++ and C# store object data differently in memory. So, but we can get that result if we want by using pointers. So this is where it gets a bit interesting. So how do we do that? So we need to make bank account 2 a pointer. Okay. So to make it a pointer, we include the asterisk symbol here, and then we want to assign the pointer to the memory locations, which means we need to include the ampersand symbol preceding bank account 1, where the assignment code is taking place here. And now, okay, bear in mind this over here, where you can see that they are clearly different values. Even though we've changed bank account 1, it has not changed bank account 2 at all. So let's compile our code. Like that. Whoops. Okay. Now, that's okay. So this is actually an expected error, because this is the other thing we need to see. I'm coming from a C# background, and this is the exact point that I'm trying to prove here, that C# is far more intuitive and less complex than C++ code, because it's actually expecting a completely different symbol here because we're using a pointer here. So you actually have to include an arrow when calling the bank statement method like this. Okay, so we've compiled our code now, and let's run our code. Like this. Perfect, and you can see now the values are identical. So by changing the values in bank account 1, this has also affected bank account 2, because we are now using pointers, which means that the object data that bank account 1 points to is the same object data that bank account 2 points to in memory. And you'll see a little bit later why this is so much more straightforward in C#. Great. Let's write the same code using C#. So I've created a new Visual Studio Code window and opened a new folder on my computer to house the code for this basic C# application. So the first thing I'm going to do is just verify what version of .NET that I'm running. So .NET -- version. Great. So I've verified that I'm running .NET version 8. So in order to create our console project, we can do it like this. We can type .NET new console like that. Press the enter key. Excellent. So it's created our program.cs file, and here we are going to create our code within this file. And you can see that it's already created a basic Hello World application for us, and we could actually run that by just typing .NET run. And the first thing to note is that even though there is no main method declared here, this code actually runs within the context of a main method. The main method, just like in C++, in C#, the main method is also the entry point of an application. So after C# 9, something called top-level statements was introduced, where you could write your code outside of the context of the main method like this at the top of the file, and it's implied that this code runs within the main method. So we don't actually have to write the declaration for our main method in this file. Behind the scenes, .NET will synthesize the main method for us, and the top-level statements will run within that main method behind the scenes. Okay, let's get rid of this console window for now, and let's create our bank account class. So to create our bank account class, we type class, then bank account like that. Great. So let's create the declarations for our member variables. So private string bank name equals 2, then an empty string. That's our first member variable. And let's declare our second member variable as decimal. So this is a floating point variable, but because it has better precision than the double in C#, decimal is actually more appropriate to store monetary values. Okay, and let's call this variable account value. And we'll just set that to 0, like that. Okay, and we want to include a public constructor here. So let's create our public constructor, public bank account, and then we must include our parameters. So string bank name and decimal account value like that. Okay. And then we can do the relevant assignments. Excellent. Okay, so let's create a method named bank statement to output our member variables to the console screen. So it's a bank statement for the relevant account. So to do that, let's make this a public method so that external client code can call our method. It doesn't return a value, so let's use the void keyword here, and let's call our method bank statement like that there. And no parameters need to be included within our bank statement. And then we want to simply write the relevant variables, the relevant values to the screen. So for bank name, include that. Then we're using string interpolation, so we precede the literal string with a dollar symbol, and then within curly braces we can include the value of the bank name like this. Okay, and let's make a copy of that, and let's output account value here. So the bank name and the bank account value is going to be outputted by this method. And let's include account value here within our code. Great. So we want the calling client code to be able to change the bank name and the account value. So to do this, because these are private, external code won't currently be able to do that. So we need to include getter and setter functionality. And in C# we don't actually need to include 4 methods to do this. We can do it via auto-implemented properties. So to create our first auto-implemented property, I'm just going to type prop, press tab like this, string, and I'm going to call this property bank name like that. And then let's include a property in relation to the account value. So we type prop, press tab. This is of type decimal. And let's call our property account value. And now we in fact don't need to even include these private member variables, so we can actually delete them like this. And we've got all the functionality we need for our bank account class. Okay, so let's remove this top level statement here and let's instantiate our bank account class. And we use the new keyword in C# to instantiate an instance of our bank account class. And we'll use NatWest for our bank. And let's put £20,000 in this bank account here. Excellent. And then we want to output a bank statement for this account. So let's go bank account 1 dot bank statement like this. Excellent. Let's compile our code. Well, let's run our code. It'll compile it for us when we go .NET run like this and press the enter key. NatWest 20,000. Perfect. So let's perform the same experiment that we did when we wrote our C++ code by creating a new object of type bank account. And let's call this bank account 2 and then assigning bank account 1 to bank account 2. And let's see what happens in our code. So let's output bank account 2's bank statement. Okay. Let's clear the screen. Let's run our code. Oops, bank account 2 is a problem. Oops, nope. Let's clear the screen. Okay, brilliant. So that's an expected result. So now what happens when we change the bank name property for account 1 to TSB like this, and we change the account value equals to 41,000. And now let's run our code. Okay. You see, by default, objects derived from user-defined types, like the bank account type here, are reference types, which means that when we assign bank account 1 to bank account 2, that the data in bank account 1 isn't copied over in its entirety to bank account 2. What's actually copied to bank account 2 is the address of where the data resides for bank account 1. So in effect, you've got two variables pointing at the same object data in memory. And we've just seen that. We've just proved that in code here, which is unlike in C++, that if you wrote the same code, a copy of the object from account 1, a copy of the object data is copied to another location in memory when you assign account 1 to account 2. So account 2 would be pointing at the newly copied data, and bank account 1 would be pointing at the original data in memory. So you would have two sets of object data in memory, whereas here, by default, these two variables, bank account 1 and bank account 2, are pointing at the exact same object data in memory. That's interesting. But the C++ code definitely runs a lot faster than the C# code, but I would say that the coding experience using C# code is far more enjoyable, and you need to write less code, and a lot of the memory management is abstracted away in C# and .NET. So we don't have to worry about manually creating code to manage memory like you do with C++. So there's a lot less risk of runtime errors occurring with C# code than in C++.